This is 2020 AMC 10A problem number 16. A point is chosen at random within the square in the coordinate plane whose vertices are 0, 0, 2020, 0, 2020, 2020, 0, 2020. The probability that the point is within d units of a lattice point is 1/2. A point xy is a lattice point if both x and y are integers. What is d to the nearest tenth? A, 0.3, B, 0.4, C, 0.5, D, 0.6, and E, 0.7. The key to understanding this problem is to realize that it doesn't matter how large the lattice grid is. It doesn't matter how large it is because wherever you choose a point, it's going to end up within one square or on the edge or in the corner. So if we can imagine just one square in the whole lattice point, like from this square right here, if we only imagine one point here, it doesn't really matter which square this is, but say these are all lattice points. So this, these are all lattice points. Because wherever we choose point, like let's use point xy or point x, let's say, wherever we choose point x to be, it's going to be inside one of these squares in the lattice point. So we can look at them all symmetrically. Now, it wants us to find the probability that the point is within d units of a lattice point. And since all four of these are lattice points, let's say we give a length d, let's say it's this far, and we can draw a quarter circle like this, because all of those points are going to be d away. So I can shade this in. All of those points there are going to be d away. And we can do the same thing for all of the sides, because all of them are also lattice points. So I'll just shade these in like that. And the blue part is where the point we've chosen is d away from the last point. So this is d, 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 and D. And it also tells us that we want the probability that it's within the blue sections to be 1/2. That means that these quarter circles combined, their area should be 1/2 of the lattice point square. And since we've chosen these to be 1 here, since they're all adjacent lattice points, that means the total area should just be, of the combined quarter circles, should just be 1/2, since the area of this square is 1. So we have to find the area of the combined circles. And that's easy because if you put 4 quarter circles together, they make one full circle. And we already know that the radius is d as we specified right here. So we just have to use the formula for the area of a circle, which is pi r squared. And since our radius is d, it's pi d squared. And we want this to be equal to 1/2. So d squared is 1 over 2 pi. So d is equal to 1 over the square root of 2 pi. And they want us to approximate this value to one of these. So we can approximate pi to 3. Since pi is 3.14, we can approximate it to 3. So d will be about 1 over the square root of 6. And if you do some calculations, this comes to be about 2/5. So this is d is about 0.4, giving us an answer choice of B.